Hey guys, it's June 19th. We got Jimmy Muller in town. We'll have some good information we're going to talk about over the next hour and a half, however long this thing takes to roll out. But obviously he's a choke guy, and I'm the guy that's always been big on shooting factory tubes, trying to be cost conscious. And is the performance really worth the justification to spend extra money on an aftermarket choke? So after the last couple days of having Jimmy and his wife in town, shooting a bunch of patterns, I think we learned a lot of stuff, at least I did. We're going to talk about that, start to finish. And so let's have at it. So obviously, background history, our good buddy Corey Loeffler from DRC Calls, Minnesota boy, back in 2018 when I was first getting Boss off the ground, he called me one day and said, "Hey man, there's these chokes that I just started shooting. You're going to want to check them out. Müller chokes. Got to call up Jimmy." So I called up Jimmy, and I spoke to a lady with a British accent that we've been joking around quite a bit.
We still don't know who it is.
And, you know who it is.
Maybe.
Yeah. And spoke to this lady with a British accent. I said, "Hey, my name is Brandon Cerecke. I started a company called Boss Shotgun Shells, and we're a direct-to-consumer, non-toxic waterfowl hunting company, kind of up and coming. And one of my friends recommended I talk to Jimmy." And this very polite but very British lady said with her British accent that I'll jot down your information, and if Jimmy deems it appropriate or necessary, he'll call you back. Jimmy never called me back. So fast forward to, let's see here. This would probably be 2019, so like a year later. And our guys go to Easton Waterfowl Festival in Maryland. And they come back and they're raving, "Man, I met this Jimmy Muller guy. I met Jimmy. He's a great guy. He loves Boss, wants to shoot, more of your stuff, wants to do chokes, this and that." I'm kind of like, well, dude never called me back. So it's kind of been a little like not frosty, but just kind of like, the last several years. And when did we start talking about the choke thing? This is last year sometime.
Yeah, last year.
And schedules get busy, things get chaotic, and finally we just said, "Hey, let's schedule a trip. Come on out here." And we kind of had this idea to maybe make a line of chokes designed around our ammunition. And that's what we kind of started doing. And Jimmy made some prototypes and spent the last 2 days shooting cardboard. There's cardboard all everywhere around us in front of the shop now. And we beat the factory tubes. You beat the factory tubes. So without going into too much detail now, why don't you tell me about what makes, first off, in your opinion and qualifications, everything else, your background, you can tell us a little bit about it, but what makes the choke as important as anything else in the gun? Next to the ammunition, the gun, the choke, right?
Yes.
All right, let's hear about it.
So basically the choke tube is the last thing that contacts your shot column before it gets to the target or the bird, right? Mm-hmm. So therefore, you could look at that and say it's pretty significant, right? So I always tell people it's like, putting plastic tires on your Ferrari. You've got a Ferrari, put plastic tires, you're not going to leave the parking lot. Choke tube's the same thing. Mm-hmm. So you could spend all this money on these beautiful guns and your trucks and your boats and your decoys and your ammo and everything else, but if you don't have the proper choke in the gun for what you're doing, your entire hunt could fail as mm-hmm. far as having luck at obtaining birds or breaking targets or whatever.
But a choke, obviously, all that we're doing simply is we're going from the barrel bore to the final constriction over the course of whatever that length may be. A mobile choke may be like 2.5 inches.
Yep.
And some of your other, like your Cryo Plus is what, 3.5?
Yep.
Total?
Longer. Yep.
All right. So if you have to go from here to here, how much science can there really be that goes into it? And that was kind of my thought.
Yeah.
And one thing I always notice, and I say, hey, with the aftermarket chokes, I would recommend for the price-conscious guy would be the Carlson, mm-hmm. but a guy with unlimited budget, only from the aesthetics perspective, as far as machine quality, exterior finish quality, the way the threads engage, everything else has always been your stuff,
yeah.
right? Unapologetically.
Yep.
But I always would find myself just shooting the factory tubes that were in it because that's what I would do all my R&D with.
Yeah, and why not?
Right.
Right.
Okay, so that said, if we're going from barrel bore to final constriction, mm-hmm. what is it that makes your stuff so much different or better?
So back in '93, when I basically had to buy 10 modified chokes from a top choke company, right, to get 2 to pattern right. I bought
Same identical choke.
Same choke. So I bought 2 modified chokes, put them in my Browning, shot them, one pattern like a skeet, one pattern like a full. So being a machinist, I realized pretty quickly that they must have marked them wrong, electro-etched them wrong, identified them wrong. So
you pin gauge them?
So I went in the shop next day and I just mic'd them.
Were they out?
And they were both 20,000 from my bore. So then the next thing I said to myself, well, this is impossible. Maybe my barrels are bad, right? Or my barrels are really, really different.
What gun was this for?
It was a Browning.
Okay.
So over and under, 325. So I'm like, assuming those barrels are awesome, because they always are. I went in the shop next day, I mic'd them. They were both very close, within like less than a thousandth of an inch to each other. So I went back out to the patterning board and I shot just threads. I took the chokes out of the barrels. I shot both barrels, and both patterns were very similar. Point of impact was dead nuts on both. So I'm scratching my head. I put the chokes back in. I flip them around. I try different ammo, different distances, and I constantly got skeet and full out of these 2 chokes. And I'm like,
and it would follow.
Yeah.
Okay.
Didn't matter which barrel, didn't matter anything. So make a very long story short, after inspecting them in depth, I found out they were out of round, eccentric. They weren't square. They weren't cylindrical. The surface finish was different. The only thing that was the same was the overall length and the exit diameter. So what I realized immediately was that the exit diameter of a choke tube is grossly secondary to the geometry that's in the choke. And then what I came to learn further down the road is that every gun liked a different geometry. So it turned into a dumpster of worms, not a can of worms, very quickly. So, and then when you throw different ammos in, and then different bore diameters of barrels, and all these different things, it changes drastically very quickly.
So one of the things we talked about, obviously both of us have manufacturing backgrounds, when you're machining that piece of steel that's going to have turning done on the ID and the OD, most typically guys are going to do the ID, then grab it in a op 20 or whatever you're going to do, and then turn the ID or the OD depending on whatever you start first. It's cheap, it's easy, right? But then you start losing concentricity, and no one would think that, well, just because I am concentric here on the ID, then you end up, I mean, you got to be able to locate off the ID then, right? And even then, it's still, stuff comes out around.
Yeah, so most choke companies, what they do is they slug the material, and then
cut a blank of it.
Yeah, cut a blank, whatever length they choose, 4 inches, 5 inches, whatever. And then what they do is they send it off to heat treat, and they get it heat treated to
as a blank.
As a blank, yep, preheat treated.
We got to do a little something here. Oh, sorry, we're good.
Good deal. So basically, what they'll do is they'll preheat treat the slugs. So not for a better reason for the end user, but for better machinability. So what they'll do is
they'll through harden it.
Yeah,
they're through harden the whole thing.
So basically, it's 17.4 pH precipitation hardness, right? So what they'll do is they'll usually harden it to like H1125 or maybe H1025, and then
what's that give you on Rockwell?
Around 32.
And starting off
it's starting off around 32. You just change
so they're just normalizing the metal.
You just change the grain structure.
They're aligning it.
Yep. So you change the grain structure from condition A, which is annealed, and because condition A annealed is not fun to machine. It cuts soft, 32.
A lot of chatter though.
But no, you get buildup. The surface finish is erratic.
It gets gummy.
Your tools don't last as long. It's just harder to machine. So in a nutshell, you preheat treat it to 1125. It cuts like butter. Your tools last. The surface finishes are great. And then you mark it and you send it off to the customer to go shoot, right? The problem is at 32 Rockwell, it's very soft compared to your barrels being 40 Rockwell, right? Most barrels are 4130 and they're hardened to about 40 Rockwell, some 42 Rockwell, but that's about where they are. So what I realized was that if I heat treated them to H900, which I could get them up to 44, 46 Rockwell very consistently.
As a slug or after?
No, after.
Post-treating?
Yeah.
Okay.
So if I do that, then they're going to be harder than the barrel. So theoretically, anything you do to your barrel, you can do to the choke. So getting back to slugging, so when you slug a choke, right, the only way you can machine the entire thing is if you do multiple chuckings.
Right.
So what people do is they slug it, then what they do is they chuck it, let's say they drill it, and then they bore the exit diameter, right, your constriction end, and they turn the OD of the head. Then what happens is the subspindle comes in, captures that head,
Locates just off the
just
OD.
off the OD of a short OD, right? Grabs the head, pulls it back here, and then in the subspindle, they go ahead and they machine the rest of the ID, meaning the taper, the gasket, the face of the gasket where it locates square to the bore, and then they do all the turning of the body, the threads, okay? The problem with that is when you draw the choke back in the subspindle, if there's a little chip or dirt on the collet, or let's just say it doesn't grab right, that choke could be running totally out of square and wobbling, or it could be running eccentric.
So how much run out do you, like, at what point, as far as run out, like thousands, do you start seeing it affect the patterns negatively?
It all depends on what distance you're shooting, right? So like the crown of a rifle barrel, if it's not dead square with the bore, the bullet's going to kick out. So if you're shooting at 20 yards versus 50 yards, it's going to be a totally different scenario, depending on how bad it is, right? So I get a lot of people, you know, they'll buy a gun, whether it's a factory choke or they'll put an aftermarket choke in, and they'll go pattern their gun. They're like, oh man, it's shooting 6 inches high and left at 20 yards. And I'm like, well, take the choke out of the gun and shoot threads at 15 to 20 yards, bench rested, and see where your point of impact is.
So is it safe for guys to shoot threads even with steel shot with no choke in it?
100%.
Okay,
Yeah.
all right.
Because that's an old myth and fallacy, because basically if you think about it, the bore diameter versus the choke area in the barrel, it's like over 1/8 of an inch per side almost. There's no way that a shot could leave the muzzle in 3 inches of length and literally
swell
go
out enough.
outward
Yep,
to
okay.
hit the thread. As you know, on high-speed photography, all the testing, basically your pellets don't start to move
About
outward
6
until it's at least, you know, several feet away,
Yeah,
right?
right,
So
right,
how
right.
can a BB hit your threads?
Yeah, fair
It
enough.
can't.
That makes sense.
It's all
Yep.
myth. It's all, you know. So anyway, so you take the choke out of your barrel, you bench rest it, you shoot, you know, your spot, and you look at your point of impact. Then what you do is you put the choke in of choice, and you repeat the process. If the point of impact is not identical, the choke is bad. No ifs, ands, or buts. Take the choke, throw it away. All right? And that's what I always encourage people to do, because that way you know exactly where the bore of the barrel is impacting. Now, obviously, if you don't have a choke in the gun and your point of impact is off, then that's gun fit. It's not the gun's fault. It's just the gun that fits you and the gun that fits me, the gun that fits my wife, all different fits on the
Right.
stock.
Okay.
That has nothing to do with
Yeah.
the gun manufacturer.
Yep.
That has to do with you fitting it to you. Once you get the gun to fit you, then you need to make sure that the choke tube is good and the point of impact is correct. Then once you achieve that, then you need to decide what type of pattern do you want based on your hunting. What are you hunting? What distance are you pulling the trigger on average? What's your maximum distance you're pulling the trigger at? And then what ammo do I need to use to obtain the best ballistic efficiency for that?
So back to the manufacturing, doing multiple loads, A and a B, obviously it sets us up for high volume manufacturing. You can use multiple machines to finish an end product. And it can be done. I mean, that's what 99.9% of every single shotgun choke made today is made in that same fashion, right?
Yep. Yes.
But there's a way that it can be done with more precision, which I noticed out of the box even in 2018 after I bought my chokes when you wouldn't call me back
Thank
to
you,
get
sir.
some testers.
Because I didn't get the message.
Yeah, right. No, so, and they're beautiful. I mean, it is like, you can tell that whoever made these things had an aerospace background. It's higher than automotive detail. I mean, this is like OCD type shit.
Thank you.
And then oddly enough, you do come from an aerospace background.
Yes.
Unsurprising.
Yes.
So, all right. So your method, obviously talking about this project, they take a lot longer to manufacture.
Yes.
Because it's all one operation. You start with, you're running these in a bar feeder, right?
Yes.
Okay. So you start with
Solid.
a bar of steel and it's normalized annealed state and you're feeding, cutting everything. So talk me through that process.
So basically, we start with a full solid bar. It's in a bar feeder. It feeds out, let's say, 4 inches out of the main spindle, and we rough face it, rough turn it. Then we drill it to full depth. Then we come in, we rough bore the taper and the straight, all with one boring bar. So we don't use multiple boring bars. We don't do any single roughing. We rough the taper and straight all together, many passes.
And you're cutting from the
Tapered end.
From the tapered end out.
Yes.
And I was told by an old school guy, machining in the direction of your shot travel is going to give you better end results with
Yeah.
your patterns.
Yeah.
Some people don't. It's hard to get your head around it, but it makes total sense to
Yep.
me when you're applying machining stresses, so on
Yep.
and so forth.
Yep.
Okay.
Yep.
The other thing, too, is your post-heat treating, too, is you're taking out a lot of that stress relieving.
Yes.
It is, right?
Yes.
Okay.
It's
All right.
stabilizing. So basically what we do is we start with all USA melted and milled material, number one. Okay, all mill spec material, always, every time. We single chuck machine it so it sticks out of the main spindle. We rough face it, rough turn it, we drill it, we rough and finish the taper and straight in many multiple passes to make sure that the geometry stays good. So like you could rough the heck out of the taper and then rough the heck out of the straight and then go in and finish them. But what happens is then you go and you turn the OD and all the stresses that you've created,
big time.
rip and rough material off, it goes out of round. So we take a lot of passes so we're not building up undue stress.
Because if you're hogging it out, you're creating all kinds of like you're almost cutting Acme threads,
Yeah.
right? Like if you
Yep.
if you really look at it, and
Yep.
there's areas where you're concentrating a ton of heat,
Yep.
and the tool's skipping over,
Yep.
and that's what you end up paying for when you're turning the OD.
Yeah, and think about it. It's a very thin wall choke, right? It's a thin wall tube that
Yeah, I
you're
mean,
turning,
how
right?
thick is the wall, or the thinnest part of the choke at the very start of the taper? Probably isn't much more than
A
60 thousandths.
A 64th of an inch, 15 thousandths.
15 thousandths, even
Yeah.
thinner than that.
Yeah.
15 thou.
Yep.
Okay.
And then you've got a taper inside there, so it gradually gets thicker as it gets toward the end of the choke. But it's still, I mean, in theory, and you know, looking at it, it's a thin tube. So you have to be very cautious on the methodology that you create, the way you cut it, the order in which you cut it, the cutting tools you use, the radii on the cutting tool, so you don't create too much pressure. So that all comes into play, and that's come into play since, you know, I mean, back when I started creating, right? So we rough face, rough turn, drill, rough taper and straight. Then we finish turn the OD. We finish face the gas skirt where it seats on the bore. Then we come in, we finish the taper and straight on the ID. Then we come in, finish thread. Then we open the door of the machine. We actually hand polish with Scotch-Brite everything.
Okay.
And not only does this, you know, clean
And
the
it's
threads
still
up
on the
and
end,
everything.
hanging off the bar.
Yeah,
at
it's
this
still
point.
still on the bar. And not only does this give us an opportunity to actually polish the threads and polish the choke, but it gives the operator the opportunity to actually do a visual and feel inspection to make sure that something's not wrong, right? So you look at the choke, you feel the choke, shut the door, cut it off, the choke's done, okay? Then on another operation, we mill the finger grooves on the head because
Okay.
those are not important.
Yep.
Okay. And we mill the radii on ID and OD, dead concentric and square to the rest of the choke.
And how are you doing that? What kind of machine are you doing that final finish?
Another
in?
CNC milling turning center.
Okay.
So everything's all done in CNC. But we do one at a time, you know, which is what I'm explaining. We don't just spit chokes out of screw machines with multiple chuckings that could be out of square, could be eccentric, could be not cylindrical, could have bad surface finishes, could have all different things wrong with them that we may not find unless we're doing final inspection on every one.
Right.
And nobody does final inspection on every part on a production.
No. It's
So what we
impossible.
do is we do. So because we make each choke one at a time, we actually, the operator, like I just said, is visually and manually inspecting each one while he's machining it. Then he does in-process inspection on every single piece. So the part comes off the machine, he shuts the door, hits cycle start, another part starts turning. While that choke tube is being made, he's measuring all dimensions at the bench while that other choke is cutting. Okay, so every single choke gets measured and inspected by the operator, which is a master tool maker, not an apprentice. Then it goes from there. Every 10th piece goes to final inspection or in-process inspection to QC. QC people inspect everything on shadow graphs, comparators. They do all thread checks, spinning them into barrels, into gauges. They measure every dimension, and then they come back out to the operator, stamp it off, and tell them, okay, keep going. Okay, and then when the batch is done, they all go into QC and get final inspection. So they go through huge amounts of inspection.
So then you've got this piece turned. You do have some, even though you're super gentle with it, you still have residual machining stresses built up in that metal. So you send
Always.
it out for heat treat.
Yes.
So how much movement is there in that process from machining stresses in a pre-hardened state to after you set it out and bring it back to heat treat?
Because it's such a thin wall choke tube, or just a thin tube, there's no volume material, it literally moves less than 3/10,000ths of an inch overall.
3/10.
Yeah.
And what's industry standard for chokes as far as your nominal dimensions for accuracy, plus or minus? Because I've seen factory chokes measure as far out as like 4,000ths.
Oh yeah.
Yeah. So
easily. So
and you guys are 1/10 of that, or like 1/15 or so.
Yeah, my tolerances on most of the dimensions that are non-critical are plus or minus 1,000th.
Plus or minus 1.
And then the critical dimensions are plus or minus 0.5 So total indicator reading of 1,000th. And
Okay.
that's also on my geometries: roundness, cylindricity, squareness, everything.
So then we were talking about heat treating. You send these out and have them. I asked if you do it in a vacuum. You don't.
No,
because people want that gold change. So when
Yep.
when 17.4 is heat treated in a standard atmosphere, it's going to oxidize and turn that little gold or rainbow or whatever, as opposed to being done in a vacuum where it's going to come out and look no different.
Yeah, there's two reasons I do that. Number one, because customers like the way it looks, and they also know that it's heat treated. But I also do it that way because I know it went through the process properly, based on the color and everything. If you do it in a vacuum, it comes out perfectly silver, like you just machined it.
Right.
I don't know if it's hard or not.
Now,
unless I Rockwell test it, and I don't have a
right.
Rockwell tester in my house.
Yeah.
you know, so
yeah.
I don't want to have to check every part that I make.
So then from there, you get them back from heat treat, then you send them out to get Cerakoted.
Yes.
And then laser engraved all your details. So
and that's the hunting chokes, yes.
Right. So yeah, we're not even talking what kind of got you the hunting thing.
Yeah, all the other stuff.
Yeah, it was originally for competition shooting.
Yes.
So largely, these chokes are like, it's a super high-end aftermarket piece. It's not just an aftermarket bolt onto your gun, like for reasons Jimmy just got done saying. And again, trust my background in manufacturing. Like the thought and OCD that goes into this is probably beyond what most people really even give a shit about.
Yes.
But you're paying a lot of money for something, and there's a lot of value added in, a lot of thought and consideration that's gone into it that other people either don't care about or know and understand their customers don't care about it. They just want a product that's going to work.
Correct.
And no shame against any other choke companies, even the factory chokes. I mean, they're designed for a purpose, and it works. It's not like we're trying to shoot, a sniper rifle with a shotgun. That's not it. But you're building it to those tolerances.
Yes.
And everything that we've done, over the last couple of days, it really does speak to that, because the way it started on like the nuts and bolts side of why I wanted to develop a line of chokes for all of our new product lines. There's 4 product lines we have now. And the challenge is these chokes have to shoot better than the factory tubes in order for me to get behind it.
Of course.
So you and I went back and forth. I sent you some ammunition, and this kind of moved kind of fast. I mean, less than a month, right? I think you've had the ammunition less than a month. You took some of your existing chokes. You made, we were shooting up in the 14s, right? So like different iterations of these chokes. And oddly enough, we were talking yesterday, sometimes when you come up with a new idea, the first idea you move on oftentimes is the best, and then the more you try to refine it, make it better and better and better, you end up going the opposite direction. Yep. So I know there's a lot of these patterns that we call it like Jimmy number 1. I think there's some Jimmy number 14s. And yesterday when we were shooting Legacy, War Chief, 12 gauge, I think your Jimmy number 1 is the best choke, like your first crack out of it. And so with that in mind, tell us, what did you do different to make the chokes that you designed with our stuff in mind outperform not only the factory tubes, not only your UFO passing decoy in no particular order, but this latest iteration? What is different?
So basically when I created my hunting chokes, bismuth was no longer even here, right? It had come and gone. And then you were the one that really brought it back and made it what it is, right? And what it could be. So you pretty much perfected bismuth the way it could be. And when I developed my chokes, I basically developed them for lead target, lead turkey, and then when I created my hunting series and I got into steel shot non-toxic, that's pretty much all everybody was shooting, because there was no bismuth, there was no such thing as TSS. We could no longer use lead for waterfowl at that point. So I basically created them for every steel load on the market to basically out-pattern everything that was out there, which I achieved.
And you started that in aluminum.
So I started my Featherlight choke series. I patented that in 2009, and that was for clay targets and upland bird hunting. Basically clay targets, okay? And with lead target loads, absolutely incredible. Don't have to clean them, no plastic, no carbon buildup. Patterns are incredible. But you can't shoot big hunting steel load through them because even though the surface is 60 Rockwell, 62 Rockwell, hard anodized ceramic, the problem is the substrate's aluminum.
Right.
So if you
Still
try to
move.
shove big steel shot through it, it's going to move. So I realized that once I got to a certain point, I would go full circle, come back to my original hunting choke, which is what I originally created for myself back in '93.
And it wasn't because you wanted a business around it. You were making stuff for your own, because you were doing, what was it? You're obviously avid waterfowl hunter, but you were doing sporting clays, competitively shooting sporting clays.
Yes.
Okay.
So I was competitively shooting sporting clays, feet task, all that stuff, and I wanted a benefit. I wanted to have something that was better than anything else, so I created my own choke. Going back,
did your scores improve and show, like you started kicking ass then once you had your own stuff?
And then as I got better and my averages started getting really good and I was becoming very consistent,
other people wanted
then
it?
Then what I did was I said, I've got to see this for myself. I've really got to prove it to myself. And I went back and I shot the old chokes that I had bought from other companies because I have them all. And the breaks were significantly worse at the same distance with the same ammo. The breaks, there were targets that I was right on. They didn't even break. I'm like, my Lord, I really did create something that's way better.
So 93, you made your first choke for yourself.
Yes, and that was for hunting.
Okay.
For the most part.
Then when did you start making chokes for other people? It started off as like buddies, like, hey, I'll make this, do this, do this.
Yeah, so back in '93, the stainless steel ones I made were for hunting. Then I actually
it's always been 17.4.
Yep.
Okay.
And then I ended up going and using those for sporting clays for a while. And then I invented my Featherlight series, which I never let anybody touch because they would have freaked out and been like, oh my God, what is this? You know, because it's like plastic, it feels like. And, choke weight went from 75 grams from competitors to 9 with mine. People were just like they would have freaked out. So in 2008, when the economy tanked, I lost all my aerospace defense companies and medical companies. And I was like, now what am I going to do? You know, so I had this choke tube that I had invented to be better than anything else. I knew it was the best in the world, hands down, because I made it that way. And I said, I'm going to patent it, bring it out of the closet, see if it'll help pay the bills.
So when was it? So that was '09. When was the first aluminum choke made?
I made the first aluminum choke in like 2004.
So you shot this thing for like 5 years before you even... Did other people know that it was just hard anodized 70-75?
I wouldn't let anybody know. I actually painted my first ones gray so nobody would know what it was. I didn't mark them or anything.
For years?
Oh, yeah.
Okay, so '09 you start doing just the choke tube business, and it's been like that to this day. Yeah.
So in '09 when the economy tanked, I lost all the defense customers, aerospace and all that. So I patented this choke, brought out a closet, a Christmas shoe for Connecticut Traveler Sporting Clay Association, and it just took off. You know, I'll never forget. I sold like 40 of them to people I knew, and like a week later, I got an order from Sweden. And I was like, how did I get an order from Sweden? I had no website, no social media, no nothing. And it turned out there was a thread done on shotgunworld.com, which I didn't even know about at the time. It's a big shooting forum. And it literally went viral because one guy talked about how good he did with my choke. And it just took off from there, you know?
So all of that you did, your own experience, is kind of like, in Boss is a similar way. Like, I had my own ammunition I built for my son and I. Now we turned it into a business like within a year or two. You had a longer run up, but you were also busy and tied up with other things. You know, I had time to burn. So, all right. So everything you learned applied from all of your competitive shooting days, all of your hunting led you to make the waterfowl choke. So in '09, so you've been making the steel choke or stainless steel choke since 2009.
So the stainless steel choke, I didn't fully develop as far as production goes until just a few years ago. So what happened was back in '09 when I did the Featherlights, that took off to the point where I was working 16 hours a day, 7 days a week in my shop, making the chokes all by myself, and I was going on back order. And I'm like, so now the next step is either buy more machines, hire more people, and be chained to a machine shop, or I could go out and build the company with my expertise, testing, competing, hunting, and let somebody else make them for me. So that's what I do now. My buddy makes them down the road 10 minutes from me, 2 shifts, 2 machines, 4 employees, constantly running them.
In Connecticut?
Yep, 150-man shop, huge ISO, all mil spec, classified projects.
But you've got your own machines in his shop.
Yeah.
Okay.
So it's a great relationship.
It's the best of both worlds. So
We're
then
good
you
friends.
end up, your heat treating is done in Connecticut as well?
Yep. So machining in Connecticut, heat treating Connecticut. Cerakote is done by U.S. Cerakote, by Steven in Pennsylvania.
Okay.
Reason being is my Cerakoter in Connecticut could not keep up with the demand because my sales are going up, and I had to go to some place that wasn't going to bottleneck. So I found Steven at the GAOS show.
Okay.
And Steven said, "Oh, we could totally do this." So he's been phenomenal. And so then he ships them to my laser engraver, which is also in Connecticut. We laser engrave them, and then I put them in the bins and we fulfill orders.
Nice.
Yep.
Okay.
But so like what we were talking about is in 2009 I did the featherlights, and I had already created the waterfowl hunting chokes for myself many years before, right? But I didn't have time to like make both. There was no way I could do both of these and market them both and sell them both and inventory them both. It was just me. So when I got to a point, I said, I need to test the market to see if people are going to receive this choke the way I think they will.
Yeah.
Just because I think it's the best, I've proven it's the best, I love it. I don't know if you're going to love it.
Right.
So I went to the Oregon Waterfowl Festival in 2011. Flew out there, took a bunch of hunting chokes with me.
And were they called?
UFO.
It was the same thing? UFO passing decoy.
Decoy passing UFO.
Okay.
And I set up a little booth there, and I had decoy companies, ammo companies, duck call companies, TV show people in the sporting sector calling me for 2.5 years, begging me for chokes. They loved them. And I'm like, all right, this is going to work.
Yeah.
So I couldn't give anybody any because I didn't have enough to really sell.
Right,
so I just basically told everybody, listen, they're coming. I'm not ready. There's just too much demand. So until 3 years
Well, the
ago,
easy thing is just to start spitting it in, slug it off, and start turning ODID, 2 different machines.
No
away
way.
you go.
Won't do it, man.
Yeah.
So it took up until 3 years ago to where I could actually have the capacity, have the right machines, the right employees to be able to expand production to the point where I could actually now produce the hunting chokes large enough to where I
And
could
that's
actually
just been
start
over the last 3 years.
Yeah, to start marketing it and selling it.
Okay.
Yep.
All right.
So
All right. So now that said, we know these things take a long time to build, just because that's the name of the game. And,
Yes.
and with what we're looking at doing, offering them in 12, 20, 28 across several different platforms. I mean, it's not going to be something that we can just all of a sudden turn on and then you can, whittle these things out in 3 days.
No.
So we're talking, obviously, first year limited release. We're going to offer this to program members first.
Yes.
We're going to use the numbers based upon interest there and kind of extrapolate that to hopefully have enough to at least make some people happy.
Yep. And where the production numbers will go.
Yeah, and then we're going to drive that for next year.
Yes.
So that said, Jimmy number 1, Jimmy number 14 versus the UFO and passing and decoy. What did you do different to make so I guess you talk everyone through constant taper from one extreme to where you're at. So how the anatomy of a choke, right?
Yes. So most chokes have a taper with a parallel section, right? And there's some chokes that are all taper, right?
Nothing hunting that you know of is constant taper, right? Or
No, and what I found with constant taper is it creates the highest shot deviation because there's no stabilization. Okay, so you get a hot core and you get a very, very dispersed and inconsistent outer
Perimeter.
fringe.
Okay.
And in my opinion, if you're using a shotgun, your outer fringe is even as important or more important than your inner core. Okay, your inner core is always going to have some more pellets just because the way that pattern works because of physics. But the outer fringe is the most important because you want a margin of error, right?
Right.
So
energy, and that's always been one of my things, is the pellets that are flying tangential to the line of aim or point of aim and point of impact is carrying less energy because it's drifting aside.
Yes.
So we kind of addressed that with War Chief and got the pattern to tighten up, but that was more due to controlling pellet drift through deformation and not as much through choke. So by stabilizing the shot, we were able to loosen the choke. So we would go from factory full to IM and have better patterns because the pellets are staying truer. But that said, if you can have a true pellet, you still need to have that drift to create the outer periphery of that. And you say, like, you hate 30-inch circle, and I'm kind of with you there. But at least for testing purposes, it's just a standard unit of measure that we can all agree
There has
on.
to be a standard that everybody
right.
can go by. There has to be, because if you don't have a standard, then what do you go by?
Exactly.
So the only reason, we could talk days about this like we do, right? 30-inch circle. If I could have 50 inches of error and still kill that bird every shot, I'd much rather have that than 10 inches, right?
Or if we could have a rectangle that's kind of short but wide, right?
Yes.
That'd be perfect.
Yes.
Okay.
So that's why I just talk about the 30-inch, the 100 pellets and all that. If I got 300 pellets, I don't want them all in a 30-inch circle. I want 100 pellets in a 30-inch circle and the other 200 outside that.
So what we have then is you've got the tube, you've got the taper section, and then the parallel section for stabilization.
Yes.
Is there industry ratios that you want a third of that to be taper, 2/3 stable?
So every gun wants something different, and every ammo wants something different. So getting back to what we were talking about earlier, when I first created my hunting chokes, I created them for basically steel shot and lead turkey loads, because that was really all people were using. And yes, some people were using bigger lead shot for pheasant, upland bird, stuff like that. But I made sure that my hunting chokes, decoy, passing, UFO, pattern, all of those really good. Now bismuth comes out. You've perfected bismuth. You're making the bismuth. You're doing all your stuff.
It's not perfect yet.
No, but you're doing.
We're going down that path. But
I mean, in my eyes, it's more perfect than it's ever been. Right. So
fair.
So it's very good stuff. So now what's happened is now we've got bismuth going through these chokes. Right.
So just the thought of, would bismuth versus steel require more stabilization or less?
Totally difficult to answer that, because it all depends. It all depends on the gun, the bore diameter, how much constriction are we looking at, meaning what type of pattern do we want at what distance with which ammo. So like what you want to shoot with bismuth 7s is not going to be the same as what you're shooting with bismuth 3s. So the geometry's got to accommodate all of that. So what we're creating and what we've created while we were here is we've realized that, okay, my decoy passing UFO patterns everything okay, but when I modified, or I should say altered, I don't want to use the word modified, people get confused. So when I altered some of the geometries in my existing chokes, we found some that out-patterned everything else with certain ones of your ammo.
And some didn't work any better, and some worked maybe a little worse.
Exactly. Okay. So that's what we're learning right now with your loads. And because it's your loads, we can cater and actually control the geometry in the chokes to make them match your ammo specifically, so they actually outperform anything else there is.
And that's what I kind of thought what we were going to wind up having is going to be a special choke for each product line, a legacy choke, a war chief choke, a steel reserve, and then Wolfram. But it looks like with testing and your input, largely, you're saying legacy war chief can operate with the same system.
Yes.
Then you're going to have a different choke for steel reserve.
Yes.
And a different choke for Wolfram.
Yes.
So let's talk about steel reserve for a little bit. And your opinion, well, just let me hear it, because I heard you talking to Dirk and some of the other guys about 100 pellets and this and this and that, and then I had to step out with some other stuff. But just know that shell we designed 35 yards and in with steel shot.
Yep.
So we want that optimal pattern, max 35.
Yes.
Okay. So take it away with your number one. For some reason, you like the 3-inch number 1 ounce and 3/8, and then the ounce and an eighth number 3s. You don't have any problem with those.
No, those were good too.
All right. So talk me through that.
So
because you shot a hell of a lot more steel than I ever have.
So here's what I've always thought. So pellet count is king, right? And you've got to have enough pellets to be able to do what you want to do. And what we've determined over the years, not only myself and yourself, but some other people, is that we want 70 to 100 pellets inside a 30-inch circle to be the correct ballistic ratio to adequately dispatch a duck or goose humanely,
regardless
with hitting
of
vitals
substrate material.
That's correct.
100's the number.
100's the number. Now, obviously, if you hit them with TSS, you probably don't need that many, because of the amount of energy and penetration.
And when we're talking TSS, we're talking, you like sevens,
yes.
right? So sevens, 7, 8, 9 for waterfowl.
Yes.
We can speak in that generality.
We can.
Okay.
Yep.
Okay.
So basically, the reason that you want that 70 to 100 pellet count in a 30-inch circle, that 30-inch circle is only a standard to give you, let's call it pellet spacing, to make it, ease of understanding. Now, if I have 300 pellets, okay, 100 pellets inside the 30-inch circle ratio, if I could have that same ratio and pellet spacing outside the 30, then that's my effective margin of error on the pattern.
Yeah, so you would probably be, if you look at like surface area, just mental rough math, that 30-inch circle would probably be close to like 42 inches, maybe even, it wouldn't be 48. You'd probably be like 40, 42 inches. You could grow that diameter and shoot a bigger circle.
And still kill that bird consistently and ethically.
Right.
So now, and of course, we always need to be on the front of the bird. That's something I always teach people. If you shoot
and you're saying most people miss because they're shooting
behind
by a wide margin.
Yes.
Okay.
So if you
finish the steel, then I want to learn through this so I remember, because we talked about it at dinner
we'll talk
2 nights
about
ago.
that.
Yeah.
But anyway, so going by that 70 to 100 pellet, we'll call it 100 pellet for argument's sake and for ease of numbers, right? 100 pellets inside a 30-inch circle is what we're trying to obtain for density and evenness of the pellets. Now, let's look at your 20 gauge, 7/8 ounce steel number one.
Yeah, you said there's only like 88 pellets.
There's 88 pellets.
Yeah.
So that's nobody's fault. It's just a diameter of a number one pellet. The way it stacks in a 7/8 ounce, that's how many you can fit.
Yeah, and for me, being the even though I do like to nerd out on math and stuff, for me it was make a shell that a 20 gauge guy can kill honkers and decoys with.
Yes. So and that's totally true. If you're shooting them inside a certain distance, which you honestly marketed inside 35, which is accurate. But in my opinion, and based on shooting lots of birds, right, inside 35 yards, your steel 3 is going to do just as good as your 1, except it's actually going to do better because you're going to hit them with a lot more pellets.
A lot more pellets.
So the energy and penetration depth of the steel 3 at 35 yards is more than enough. So you don't need a 1.
Well, I get that. I'm with you.
Yep.
When we came on with bismuth, people were asking for number 2s and BBs, and we're like, no, shoot number 5s.
Yeah.
So to take a like product, steel versus steel, and it's relatively commoditized at this point. Now we've put some fancy, wad technology in it and kind of make it shoot nice and soft and patterns really well. It's still steel shot.
Yes.
And guys want BBs or triple B.
Worst thing you could do.
And we're making it in 1s and 3s. So it's kind of like a compromise, getting people more towards, you have pellet energy, you got pattern density. You need to have both to kill a bird.
Yes.
Unless you're shooting sniper rifles, right?
Yes.
And are a crack shot. So that said, you're telling me that guys miss behind the bird. And you and I chatted at dinner the other night about shooting motion, because I've seen a lot of your videos when you're shooting divers and even pheasants out at 80, 90 yards, and you can shoot, right? Obviously.
Yeah.
But I would see I've been taught to swing through instead of shooting a sustained lead. But you do something where you kind of pick the bird up on the front side of it, and then you come in front, you'll shoot a sustained lead, and then you'll pull the trigger. Mm-hmm. So when I would shoot sustained, I would try to get out in front of the bird, hold the lead, pull the trigger. But yours is kind of like a modified, almost like a pull away. Mm-hmm. But instead of like me going like, you see the butt beak blue bang.
Butt beak bang.
Yeah. Right. You're kind of getting
Bs.
on the front of it, then pulling your lead, then pulling the trigger. So walk me through that, how that works.
So let me explain this. So basically your eyes are going to go to the fastest moving object. Okay, so if you start behind an object and you have to catch up to it, pass it, and lead it and pull a trigger, your barrel is moving faster than the target. Therefore, your eyes are going to look at the barrel, check your lead, and you're going to stop the gun and you're going to shoot behind the bird.
Still be behind it.
And you're not going to know you're doing it. So that's number one. Number two, if you're starting behind the bird, your brain is screaming, catch it, pull a trigger. So what's happening is everything's fast, you're out of control, your gun is rocketing up to catch the bird, and 9 times out of 10, when your barrel gets to the bird, you pull a trigger and you shot way behind it. and then you do it 2 more times, bang, bang, and you still shot behind it in the same exact spot.
Yeah.
So
I think we've all done that.
Yes. So
Okay.
so anytime that a target passes your muzzle, it's in control of you. You're not in control of the target. Okay. So it's sort of like stopping on a on-ramp and then trying to merge into traffic. Okay, unless you got a Ferrari, you're sort of struggling, right? So the thing is, if you're merging into traffic, you want to be going at least as fast as the traffic, if not a little faster, for a smooth merging. Same thing when you're shooting a moving target. So what you want to do is you basically want to come up to the target, okay, and sort of match the speed and feel the target. Feel where it's going, look where it's going, and then extend the lead out to where the bird is going. And when you get to the right sight picture, either make sure it's right by sustaining it for a little while or just pull the trigger when you get there. But either way, you're controlling the target from the front. You're slowing everything down. You end up with way more time, total control of the target, and you're literally waiting for the bird to just die.
So shooting mallards, greenheads,
Yep.
on a crosser,
Yep.
average flight, let's say 30, 40, 50.
Yep.
What was you told me your leads before. So you're 2.5 to 3 feet at 30.
Yeah.
And then you're like 4 to 6 feet at 40.
Yes.
And then 8 to 10 feet at 50.
Yep. And then after 50, it gets really big because the obviously velocity just dies off.
Right.
If you're shooting steel, that gap is huge. That increase is huge. If you're shooting TSS, it's a lot less.
But you were saying even inside 40 yards, or was it 30 yards, the difference between steel and bismuth, obviously 1,500 steel and 1,350 bismuth, it's no different.
No.
And that goes out to what? Was that 30 or 40?
Yeah, so basically if you're shooting inside 25, it's very different. So basically if you're shooting like 1145 feet per second and 1,500 feet per second at 25 yards,
Yep.
there's a significant sight picture difference.
At 25.
At 25. The moment you exceed 25 and get to 30, it starts to become a little closer. The moment you exceed that 30-yard mark, it's almost insignificant enough to the point where you cannot see it or you won't see it.
The difference between the two.
The difference your pattern's going to make up for. The way you move the gun with the bird and the way you squeeze the trigger and what you see is way more important than the amount of difference in feet per second.
So if nothing else, that whole thing with, I'm going to try that.
Yeah.
Maybe on some sporting clays or even shooting trap loads or whatever in the backyard, but picking up on the front edge of the bird, then establish. So you can either, I guess, spend your time catching up to the target, getting in front of it, or pick it up on the front side of it, then get your lead set and then pull the trigger.
Yep. So one thing that I always tell people that's very helpful, I think, is you always kill a target with your eyes before the gun does anything. The gun is just a tool to finish the job. So if you don't kill a bird with your eyes before you try to do it with the gun, you're not going to kill a bird with the gun. Okay, the gun's not going to do it for you. You need to do it before the gun is applied. So every target that I shoot, whether I've got tons of time or whether I get a bird that stuffs me from behind and comes skyrocketing over my head, I kill that bird with my eyes before the gun even gets to the bird. That way, when the gun does get to the bird, it's dead already. So that's how I control things and slow them down.
All right, so back to the guts of that choke with what you like to say you altered, didn't modify. The parallel section, you basically took like one of your standard choke tubes, and then you bored it larger.
Yes.
Effectively increasing the length of the parallel
and shortening the taper.
Right? And that seemed to work really, really damn good.
Yes, on most of the loads.
Okay, what ones did that not work on?
And then I've got to go back and look at it, but it was pretty evident on some of the loads. The one where I increased the length of taper, it worked better.
So on one of them, longer taper, shorter parallel outperformed.
Yes.
Was that with steel or was that with bismuth?
I can't remember.
But that's what's going to roll into the production version.
Yes.
Okay.
And then on some of them, the longer parallel and shorter taper worked better.
So, and that was not.
And that was the same
specific.
gun. That was the same gun. Yeah.
Same shell.
Yes.
Okay. So, like what I did with War Chief 12 gauge, that was a 2 3/4 load. we ended up investing $1 million in tooling on the thought that what I just did with a 2 3/4 12 gauge, I can do with a 3-inch 12 gauge, I can do with a 20 gauge, I can do with a 28 gauge.
Yes.
Right? And it's kind of a ballsy thing, but when you're confident and you know, if you think in the right mindset and engineering wise, like you and I like to think,
yeah.
if I do this and this and this and this works here, it should work if I do this and this and this a little bit different over on, taller shot count, smaller bore, this, that, the other.
Mm-hmm.
And that's kind of how you're at with being able to take what we learned with Benelli CryoPlus, Benelli Mobile 20 and 12, and then you're going to be able to take that and make that same idea work for Beretta, Browning,
yes,
everything else, and then including 28 gauge, because you didn't have time to turn any 28s for us.
Correct.
But you already know what to do. Then
Yeah.
it's just a matter of proving it on paper
Yep.
and then rolling it out.
Yeah. So way back when I created the Featherlight series, I did all this already, but I did it for lead target loads.
Mm-hmm.
So I've got knowledge as far as how guns performed with those lead loads. Now, even though bismuth is not lead and steel is not lead, it's still physics. Mm-hmm. So I have a good idea of what's going to like what based on what I've already learned. And now what we've done here in the last couple of days, it's confirmed a lot of things. So
Mm-hmm.
now I have a direction to go in for you and to make it better than it's been. Going back to the whole factory choke, because I know people are going to ask. Okay, so we got to talk about
Well, I held out longer than anybody, I think.
So the thing about
part of it was because the British lady.
So the factory chokes, if you look at some of those patterns, there are a couple factory chokes and a couple ammos. It looked really freaking good, okay?
Mm-hmm.
But here's the thing. It looks really good with that choke in that gun with that ammo with that shot, okay?
Right.
Meaning that one shot or those 2 shots or 3 shots. Here's the problem with factory chokes. They're not hard. They have limitations, okay?
They don't harden factory tubes?
No, they don't.
Same thing. It's
They're
just a slug. Do they even pre-harden the slug of 17.4?
I don't know what they do, but they have limitations for a reason. You can't shoot steel BB through a field.
I thought that was
choke,
just
or you
because
can't
it was
use
too
this.
tight inside a flush mount.
No.
What?
No. It's because it'll expand into your threads, your barrel, and swage in, and you won't get it out.
I thought that's why you have to run an extended aftermarket tube of a tighter constriction, because all of that pressure is outside the gun. It's because the choke hardness
the pressure
isn't
is
there.
still inside the barrel because in order for the pressure to be outside the barrel, you would have to make it so long nobody would buy it. And the other thing is the geometry wouldn't work right because it would have to happen sooner. So basically, factory chokes have limitations because they will expand into the barrel if you shoot stuff too big through it.
And that has nothing to do with, you're shooting BBs or T-shot through it.
It
I mean,
has
that'll accelerate. It has a lot to do with it. That'll accelerate it. It's going to happen
It has
regardless.
a lot to do with payload as well as pellet size
And
as well as
velocity.
velocity.
Okay.
So like if you shoot a 1 ounce steel BB through choke A, it may be fine. If you increase it to 1 ounce and 3/8, it'll seize up the first shot.
And because your stuff is, it's not to say it doesn't happen, but it's tougher.
Yeah.
Because you're heat treating it for toughness, and you're walking that line. You can't make it too brittle,
Yep.
right, where it's going to shatter.
Yep.
But with too much heat treatment.
Correct.
But you're hardening it more so than just a standard 17.4 pH
Yes.
standard untreated.
Yes.
Annealed. Annealed is actually soft, right?
Yes.
So is 17.4 or machining stainless? I don't know. I know on 5000 series aluminum, that work hardens when you start working with it.
Mm-hmm.
Does 17.4 work harden itself with machining or not really?
It could work harden, but it doesn't.
It doesn't.
Unless you did something really wrong.
Okay.
You
So
know.
if you're doing it right, 17.4 doesn't get tougher just by machining it.
No, it does not.
Okay.
Nope.
So I didn't know factory tubes are not post-treated.
No.
Almost every aftermarket
They'd
choke
be
tube
too
is.
expensive. They'd be
cost.
too expensive. You get what you pay for. Factory chokes come with the gun. And I assure you, they don't take choke tube cost into consideration when they price a gun. Okay.
No, didn't you say that one of the manufacturers was a big name manufacturer was supplying chokes for like $2 or $3,
Yeah.
which is
Yeah.
under the cost of the metal to
Yeah.
procure.
Yes. So some factory chokes, the choke manufacturer charges like charges the gun company like $3 each. So
And your cost of material is higher.
myself knowing that my cost of material is more than that per choke, just the material, how can you do that?
Well, I mean, you're
So-
using, like you say, you're using like certified aerospace grade,
Yeah.
mil spec quality stuff.
Yep.
You can get off spec standard 17.4 bar stock all day long for probably maybe not half the price,
A little
but
cheaper.
30% less, 20% less.
Yeah. But still, I mean, and then we talked about like one of the major gun manufacturers that knows better. Their hunting guns came through the factory with extended chokes for hunting.
Mhm.
They're made out of 303 stainless. The only good thing about a 303
won't
stainless
rust.
choke is it will never rust. But it'll gall inside your steel barrel. It could weld the threads to the barrel. If you got anything, one little chip off the thread, you'll never get it out. 303 stainless, the moment you shoot steel shot through it, you're going to swell a choke, which I proved. And I'm not even talking big steel shot. I'm like, what are the gun companies even thinking when they're doing this
And
stuff?
this is name brand stuff
Oh, big name brand.
in the
yeah.
waterfowl world?
Yeah, big time. Yeah.
Okay, well, I got a question for you. I haven't asked you this. A choke swell or a barrel bulges at the choke barrel interface,
Yep.
or a barrel ruptures right at that choke interface.
Mm-hmm.
How, to me, that's not the shell that did that. That's a choke either backing out or a choke cracking, and I've seen both. We've had customer issues with both on a handful of occasions over the last 5-6 years. Not that much, but enough that it's memorable for me. That not enough. The people, I guess, are what makes me remember it. One guy was really cool when I kind of broke down what happened.
Yeah.
Another one said it was still my shell that blew up the end of his. Neither here nor there. How far out does a choke have to unscrew before it's going to cause a catastrophic failure?
So first of all, let me tell you, ammo will never cause failure of a choke tube as far as that goes. Okay, if you're shooting big steel shot and it swells the choke into the threads,
That's
the
one
choke
thing.
will get stuck in the barrel.
Yeah.
Okay, that's it. But your bismuth, especially, is never going to damage a choke. It can't. So what happens is back in the day, if you remember, there was a company or two that made a certain wad that got stuck in some chokes, and then people fired the gun again
Yep.
and blew the end of the barrel,
Yeah,
right?
yeah.
Thank God nobody got hurt or anything. It's on the end of the barrel. But that was not the ammo fault. It was the wad with the choke fault. So that choke tube,
So there was a
Cor-
choke that could fire the
There-
shell at 1500 or whatever it's
and capture the wad.
and kept the wad.
Captured the wad, and then the follow-up shot, you got an obstructed barrel.
Whoa. Was that
Yeah.
like with wad strippers that was grabbing it?
Yeah.
Okay.
So
There's a handful of guys out there. We're not saying
That
we're
was a
not
bad
naming names.
situation,
Okay.
but they fixed it. They changed things and
Right.
fixed it. But that's just an example of what could happen.
Yeah. I'm talking where
that's sort of out of control of the,
The barrel swells, the choke goes flying type
Yeah.
of thing.
Yeah.
Or that I've seen it where a choke it was a Beretta Optima
Yep.
choke, the one with not the best thread design or
Yeah,
whatever.
it's a very thin wall
like
choke.
an Acme
very
thread,
long,
flat
very
thread.
thin.
Yep. One of those backed out, and you could see where the end of the choke like peeled in.
Yep.
Like something forced it to roll
Yep.
in, and then it cracked,
Yep.
and then messed up the barrel.
Yeah. So
How
so
far
here-
out did that guy's choke have to get twisted?
So here's something that was common that happened. It was unfortunate because it happened, with Beretta. It wasn't Beretta's fault. It was the user's fault, in my opinion, because you should know what you're doing with your firearm.
Mm-hmm.
So basically, when they switched from Optima choke to Optima HP, the reason the HP is there is it's Optima high performance, but it's a different thread position. What they did was they moved the threads down approximately 3/8 of an inch
So you can
from the
leave the wall
original
thicker above it?
Optima. Yeah.
Okay.
So what happened was some people wanted the high performance version. They bought an Optima HP choke screwed into their Optima barrel,
It had the
and
gap.
the choke stopped 3/8 of an inch from where it needed to seat.
And it was
But-
stopping on the threads running out on the choke body,
So
not
what happened
seating
was
anywhere.
when it bottomed out on the threads, it cocked the back of the choke off a little bit, and people shot the back of the choke, and the shot went between the choke and the barrel, and they bulged the barrel. And then, of course, people freaked out and said it was the choke. It had nothing to do with Beretta. It had nothing to do with the barrel. It had nothing to do with the choke. It had to do with the person not knowing what they were doing and putting the wrong choke into the wrong barrel.
But it was the same pitch of thread?
Well, yes.
That's kind of
That-
an engineering, like the engineering guy was,
I would have changed that.
yeah.
But still, you should still know what you're putting in your gun.
Right.
You know,
Right.
you're the user.
Unless
read
the guy
the
doesn't
manual.
know the difference between Optum, HP.
Yeah.
I can see both
Yeah.
sides of that, but
Yeah,
still,
it
that's
can
what
happen.
happens if a choke backs out.
If the choke doesn't go all the way down, don't pull a trigger, man.
And then the other one too, you were telling me the choke obviously has to seat against the
gas skirt, I call it.
of the barrel internals, not
Yes.
the muzzle, because
Never.
that's not a critical dimension during the manufacturing
That's
process.
correct.
I mean, it's critical, but it's got a wider tolerance. on
Yeah,
it.
gun manufacturers, barrel manufacturers don't care about the end of the barrel. They just chop it off. So the down inside where the choke is supposed to seat, down inside the barrel, that face down there,
Yep.
that face is square with the barrel bore, and it's also square with the rest
choke.
of the choke area that they thread in. So that way, when the choke is manufactured properly, like we do, you screw it down, that thin end of the choke seats square on that face.
And you
so
said you
everything's
leave
square.
a gap above like 40 thousandths.
It all varies because there's a lot of tolerance in the industry of barrels.
Barrel length, yeah.
So like barrel to barrel, you'll see sometimes 30, 40 thousandths difference in some guns. So what I do is I take a bunch of barrels, I measure the depth, okay, and then I find the deepest one, and I make the gap from the end of the muzzle to the end of my extended head 15 to 20 thousandths
15, 20,
longer
over the longest.
over the deepest
So when
one I
guys
find.
screw the choke in and there's a little gap where you can stick your fingernail in
That's
there,
important to have.
it's supposed to be there.
Yes. The gap could be 1/1000th of an inch, or the gap could be 1/8 of an inch.
Yeah.
I don't care as long as there's a gap.
If you put a Cryo Plus in a mobile, you have like an 1.5 gap,
Yes, you do,
and they shoot.
and
good.
it's still great.
It shoots great.
Yep.
Yeah.
Yeah, it's only one of the only ones. You know, one thing that people get into mentioning that, and this is good to mention, is because especially new Benellis that are out, people doing modification on the barrels, like Rob Robertson backbores them or overbores the barrels to 733. It now takes a Beretta Optima Plus choke. It no longer takes a Benelli Cryo
Oh, they
Plus
changed the
choke.
threads.
Yep, and Briley also does that same work with those guns and those barrels.
So tell me, you hit on this, being that you brought that up, I'm glad you did. You said yesterday that the tighter bore shotguns are better for waterfowl hunting than the loose bores, generally speaking, and why was that?
So if you're shooting, regardless of what you're hunting or shooting, if you're shooting further distance games, you should be starting with a tighter bored barrel because you have to choke it down less for it to perform tight at long distance and ballistically efficient. Think of it this way. If you've got a Mossberg 835, 935
Yep.
Ultimag,
I've got two of
that's
those.
on a 10 gauge bore. It's 777.
And it's a shooting son of a bitch.
Yep.
The patterns
Oh,
are unreal.
It's incredible. Turkey loads and big payloads, there's nothing like it.
Yeah.
Unless you're shooting a 10 gauge, right?
Right.
But for a 12 gauge, the Mossberg 835, 935 is incredible because you've got a huge amount of payload and that bore diameter can handle it without screwing it up.
Okay.
But if you take that bore diameter, just as an example, I'm not throwing Mossberg under the bus by any means. Take that big bore diameter, 777, and then you take like an old Beretta mobile choke or a Benelli,
Yeah,
right, with a
720
720 bore.
Yeah,
Let's call it
720.
720 for a round number because they vary from 719 to 724.
Okay.
So we'll say 720. That's 57 thousandths of an inch different with no choke involved at all. That's just barrel bore diameter. So obviously, in order to, let's say, get it down to 700, right, if you take 720 to 700, that's 20 thousandths, which is nothing, right? You go from 777 down to 700, that's 77 thousandths of an inch
That's
constriction.
it's a 3x increase in the amount of constriction. We were talking about that the other day too,
Yeah.
where a 30 thousandths on a 720
Yep.
is let's see here, 5%. It's like call it 5% constriction.
Yep.
Not 5%. To do the same, to go from like 775 to that same 30 thousandths constriction is it's a lower percentage number if you only go 30, but to go to a final taper, it's a lot more.
Yes.
But why can't you say if I constrict 3% on this bore and 3% on the bigger bore, which is a looser final diameter, shouldn't that pattern about the same?
It can't. It doesn't.
So choke is defined. What you're saying, choke is defined as like a total number of constriction, not a percentage relative to the initial bore.
Yeah, so all these years, ever since choke was created, choke tubes, let's say, we'll just talk about choke tubes. all manufacturers went by 5/1000ths of an inch increments. So 0 is cylinder, 5/1000ths is skeet, 10/1000ths IC, 15 light mod, 20 mod, and so on.
Regardless of gauge.
Regardless
and regardless
of
bore
gauge,
diameter of the barrel.
Regardless of bore diameter, regardless of harmonics of the barrel, regardless of how the barrel's machined, regardless of the length of the choke they make, regardless of taper length, regardless of parallel length, they just throw it out there and they say, this is an improved cylinder because it's 10/1000ths constriction from your bore. It's not real. It doesn't work. If you take the same exact choke that I'm sure you've done, I've done it. If you take the same exact choke from the same exact manufacturer, right, and you put in the same gun and shoot the same ammo, your patterns vary. And why is that? It's because the geometries in the choke are not identical to each other, which is why I was very, very picky about making the chokes exactly the same for each series that I make, based on how that gun likes it the best. Because I knew that the moment you change surface finish or parallel length or taper length or gas skirt clearance, overall length, exit diameter, it all changes. So I'm like, not only does the geometry have to be perfect, but you need to figure out what that geometry needs to be.
And you've got that dialed in.
Oh, yeah. Yeah.
Well, perfect.
Yeah.
Perfect. So I guess the plan is you're going to fly back tomorrow morning. You're going to get us our 28 gauge you're going to work on.
Yep.
We're going to rip this podcast, get an email out, get the word out, and then it looks like we're going to have 3 chokes. The bismuth that's going to carry Legacy War Chief, then we're going to have a Steel Reserve, then we're going to have the Wolfram.
Yes.
And we're going to have pre-order for custom program members. After a week, maybe, we'll put our final order in for the year. And you're talking mid to end of September for which one? That's like the first SKU coming out.
Yes.
So, I mean, it's going to be tight. Like, if in order for guys to get these for hunting season, we're going to have to really kind of figure this whole thing out. But the good thing is, as soon as you get them, it's going to be optimal for the product line. Now that we're manufacturing all of our own wads, we've got a couple years of experience in our belt with War Chief. We can make Legacy like no one's business. Steel Reserve has been optimized based upon War Chief engineering.
Yep.
The War Chief wad is now going to start making its way into Legacy that we've modified a little bit. In some regards, we haven't had to use it. It's just a bufferless shell.
Yes.
That's actually patterning a little bit better than some of the Legacy stuff. And then War Chief technology made its way up to Wolfram. So now that we know how everything is, it was perfect timing to pull this thing together.
Yeah, it's going to work good.
I'm still pissed at that British lady.
I am too.
Because we could have done this a hell of a lot sooner.
I am too.
But anyway, I'm glad you made the trip. I'm glad we made it. Yeah.
It's good stuff.
Yeah, exactly.
It's good.
Well, cool. Well, that's a wrap, I guess. Look for more stuff coming soon.